Hello, this is Steve Payne of INEMI, and welcome to our webinar introducing the new project on hybrid PCBs. We'll be getting started in about 4 or 5 minutes' time. Thank you. Hi there, this is Steve Payne of INEMI. We'll be starting the webinar in about 2 minutes' time. You've probably noticed that when you've joined, your camera's disabled and you've been put on mute. We've quite a few people joining this webinar, but there will be an opportunity to ask questions at the end of the webinar through the chat function, or you can always email me after the event. But we'll be getting started in about 2 minutes' time. Thank you. Hi there, we're going to get the webinar started now. Welcome to our webinar. Our INEMI webinar is to launch our call for participation for the new INEMI project, Hybrid PCBs for Next Generation Application. My name is Steve Payne and I'm Project Manager for INEMI, the International Electronics Manufacturing Initiative. Today I'll be joined on the webinar by Sarah Zapluski of IBM. Sarah is a Senior PCB Qualification and Reliability Engineer and a Master Inventor at IBM in Rochester, Minnesota. Please note that this webinar will be recorded and the recording will be available. There will be a link through our website. Now, this is the agenda for today's webinar. I'll be describing the INEMI project development process. And as I'm expecting some non-members on this webinar, I'll start by briefly introducing INEMI, and also I'll describe some of the various current PCB-related projects and initiatives. Then Sarah will describe the project background, scope and objectives. And then to finish off with, I'll describe the process of joining the project for INEMI members and also the process for non-members. And as I mentioned before, at the end of the presentation, there'll be an opportunity to ask questions via the chat function. So for those of you not familiar with INEMI, we're an industry-led consortia of electronic manufacturers, suppliers, associations and universities. We're not for profit and we're funded by our membership fee. We're truly global. We've got offices in North America, Europe and Asia, and members spread right across the globe and really representing the entire supply chain of electronics manufacturing. Our mission is to forecast and accelerate improvements in the electronics manufacturing industry, and we achieve this through our technology roadmap and our collaborative research projects. That's a key benefit of membership is the participation in our collaborative research projects. They reduce cost to our members through leveraging resources of the whole project team and reducing risks of technology introduction. We have a 25-year heritage of very successful projects that have addressed knowledge gaps in our industry, and they uniquely bring together a global supply chain. Our membership covers all sectors of electronics industry, consumer telecoms, medical, automotive, aerospace, and all aspects of the supply chain, in addition to academia and research institutes, and also other trade organisations who we work very closely with. INEMI staff, such as myself, we facilitate the projects, but members can also suggest projects which typically last 12 to 18 months, and they cover a wide spectrum of topics. You can always find an up-to-date list of our projects on our website. Very briefly, over the next 2 or 3 slides, I'm going to describe some of the current projects and initiatives concerned with PCB fabrication and related topics, in addition to today's project, which you'll hear about in detail from Sarah. The first at the top is a project that's been going for a little while, reliability and loss properties of copper foil for 5G applications. It's looking at surface topology of copper foils, including the oxide alternative treatments, and investigating the metrology used in non-contact surface measurements, also looking at surface conductivity, and importantly, signal loss in copper foil at high frequencies, and also the reliability issues that are related to adhesion of very smooth coppers to low loss resin systems. The project in the lower part of the slide is just starting. That's looking at CAF and ECM failures, particularly looking at areas such as microvia hole structures, in addition to considering low loss dielectrics and other materials, and also at higher voltages. Now, these next couple of slides show some initiatives, which is an early stage of project. The top one is concerned with looking at the challenges of the connector footprint tolerances. As you can see here, an example of a drawing, which can be a challenge to fabricators. The lower one is a new project just starting out at concept stage, which looking at the electrical characteristics of PCB materials immersed in cooling fluids, which is becoming more and more favoured in data centres and aspects like that, applications like that. The last two I'll briefly describe. 2 topics. The top one is pad cratering and pad lift characterization and mitigation, and the bottom one is looking at electro-optical PCBs, optical PCBs. So if anybody has an interest in one or more of these topics, please contact me, email me after the webinar. So this next slide depicts our project development process. Now, project ideas, the input from them at the top of the slide, they often come from our technology roadmap through a gap analysis, which identifies key issues that are best solved through a collaborative effort, pre-competitive collaborative research. And it can come from all aspects of the electronics manufacturing supply chain. I should mention that our future roadmap will be an online service. It's currently under development, and we're in the stage of publishing various chapters, and that will continue throughout next year. In addition, we hold workshops and other events. And lastly, but very importantly, INEMI members can propose new ideas for consideration as a project. During stages 2 and 3 that you see in the slide, an initial project team is formed and a detailed project plan, or we call it statement of work, is defined and objectives agreed. And that then goes forward for approval by the INEMI Technical Committee, after which the project proper can start. From stages 4 and 5 onwards, when the project proper starts, the project's limited to INEMI members only. And I'll explain a bit about that at the end of the webinar. I think I mentioned these are some of the project documents we have. The SOW, Statement of Work, which is the project plan, which sets out the project scope and benefits, the tasks, etc., and the project schedule. And we'll see some of that as we go through the slides. And also there's a project statement which is signed by participating companies to commit them to the resources required for the project. Projects are always industry-led, and INEMI members such as myself, INEMI staff such as myself, we just facilitate the project. So project chairs and leaders come from our active membership. So let me now pass over to Sarah, who will describe this new project in detail.
Yep, thanks, Steve. Hi, everyone. I'm Sarah Czapleski. I'll be giving a brief overview of this hybrid PCB project. Starting out with some background. So hybrid PCBs use 2 or more different dielectric materials in a single stack up, usually to balance electrical performance and cost. So you have lower loss materials on the high speed, high performance layers, and then higher loss, low cost materials on the power, ground, or lower performance layers. An example hybrid stack up is shown at the right, where the blue and green layers represent 2 different dielectric materials. Utilization of hybrid PCBs in the industry is becoming more and more common due to the need for higher data rates, which requires use of more expensive, lower loss materials, as well as demand for increased functionality, which can drive higher layer counts. So now you have more layers of more expensive materials, and a hybrid stack up can help reduce the material costs associated with that. However, compatibility of the dielectric materials used is critical for ensuring manufacturability, quality, and reliability of the printed circuit board. Therefore, the materials must be carefully selected and the manufacturing processes must be optimized. So it's against this backdrop that the INEMI PCB TIG highlighted hybrid PCBs as a critical topic to initiate a project on. Next slide. So as some of you may be aware, there was a phase 1 of this project, which was an industry survey. We polled laminate manufacturers, PCB manufacturers, and OEMs with their overall goal of understanding the key design, manufacturing, and reliability challenges to pinpoint what kind of project we wanted to focus on. So just to highlight some of the results, we found that determining material compatibility and managing warpage are the biggest manufacturing challenges, and that DOE's trial run scout lots, a lot of hands-on optimization is needed to effectively manufacture hybrid PCBs. And then that the CTE, rheological properties, desmear rate, and chemical compatibility are some of the most critical material property parameters to be considered. So taking into account the results of the survey and the results of some of the end of survey webinars, we asked, what projects would people be interested in? We identified the opportunity areas that are shown at the bottom of the slide. So, there's opportunity to improve understanding of how material placement in the hybrid stack-up affects PCB quality and reliability, as well as, opportunity to learn more about how the material property mismatch impacts PCB reliability, and then better understanding of the drivers of warpage asymmetrical stack-up and how the hybrid influences via and microvia reliability. So taking all of these things into consideration, the initial project team formulated phase 2, which is what we're formally kicking off with this webinar. Right, so the overall objective of phase 2 is shown at the top here. Our objective is to evaluate how placement of dielectric materials with different properties within the hybrid stack-up impacts thermomechanical performance of printed circuit boards. And for this phase, we'll do it using commercially available simulation software. So we're going to be creating different stack-ups and running thermal cycling to see how they perform. And this will allow rapid screening of the stack-ups, reducing the time and cost investment, and actually enabling evaluation of more designs. After some review of different software packages, our plan is to use Gauss Stack by Avashtec. This software enables you to create many different customizable stack-ups with a wide range of materials in their library. And then you can create via stack-ups, run simulated thermal cycling, and get an output of cycles to fail, as well as a projected output of PCB warpage. So through multiple subtasks in this project, we're going to study the impact of the following on PCB warpage and via reliability. We're going to look at the degree of property mismatch, material property mismatch. So some things we may consider will be z-axis CTE, XY CTE, gel point, etc. We'll be looking at how the material placement within a symmetrical stack-up impacts warpage and reliability, as well as the ratio of the two different materials. And then we also want to look at resin asymmetry in the stack-up and how that affects warpage and reliability. For this project, we'll be focusing on thermoset materials rather than thermoplastic materials or rigid flex type hybrids. And we hope to manage this as a quick turn project, targeting completion in around 1 year. Next slide. So now I'll go into a little bit more details about the various tasks. So we broke this down into 5 tasks. So the first one is just to, with the new project team, finalize experimental design. We'll select the fixed stack-up parameters, so like the number of layers, the copper weight, etc. Select what via structures we want to use, including the PTH diameter, what plating thickness we want to assume, microvia configuration, and then also select the thermal cycling regimen that we want to use. And then task 2, we'll start getting into the simulations. And so the goal of task 2 will be to study the impact of material property mismatch and placement on warpage and via reliability. So the team will be selecting the dielectric materials and what specific properties we want to evaluate, and then define our experimental design, conduct the simulations, and analyze results. So to kind of illustrate what task 2 could look like, there's a potential, stack-up design DOE on the right. We have 3 different sets of 6 stack-ups, right? Each letter kind of represents a different material. So if you just look at the top row, materials A and B, you can see there's different placement scenarios of where you could put material A versus B in the stack-up. And so that's what we would be evaluating as far as how we're going to look at material placement and how that impacts warpage or via reliability. And then with the simulation software, we can actually tweak the material properties intentionally. So that's why there's kind of 3 sets here. As you can see, maybe looking at, for example, z-axis CTE, you could intentionally create a mismatch and then actually see how that mismatch impacts warpage or via reliability. All right, so this is just an example, but the project team will be defining our specific DOE that we want to run during the project. Next slide. So from there, task 3 would be study the impact of the material ratio. So that's illustrated at the bottom left, right? So just changing the ratio of material A to material B in the stack up and seeing how that impacts things. And then task 4, similarly looking at resin asymmetry. So kind of we take the results of task 2 and 3, select a material, A to B ratio, and then change the placement within the stack up to create this asymmetrical resin hybrid, and then evaluate the results with the simulations. And then the last task would be project wrap-up, including our final summary of results. Next slide. So this is the INEMI is not analysis. I just kind of went through what the project is, so I'm not going to focus on the left side. I'll just briefly highlight what we're not going to be focusing on. So the purpose of this project is not to recommend or promote any specific suppliers of materials, PCB, or simulation software. We are just using one software tool, but that's just kind of focused on for this project. It's not intended to promote that particular software. Also, we won't be providing pricing. We may consider relative cost impact of different stack ups, but we're not going to be providing exact pricing. We're not going to be building any PCBs or test vehicles in this phase of the project. Like I said, we're not going to be focusing on rigid flex or thermoplastic materials. The main focus will be a combination of different thermoset materials. We're also not going to be studying the electrical performance of the hybrids, and we're not trying to directly compare different PTH or microvia designs. The purpose is really to understand how the thermomechanics of a hybrid influences a selected via or microvia configuration. Next slide. So as far as project deliverables, at the end of this, we want to have a final report and webinar summarizing the results of our simulation studies, and depending on the results, hopefully have an industry publication as well at a conference. We'd also like to have a design and manufacturing guideline or checklist document created for hybrid PCBs, incorporating the information from the survey phase 1 and what we learned in phase 2, and then any knowledge from our project team. And then lastly, we will recommend stack ups to actually manufacture in a potential phase 3 of this project. Slide. So as far as kind of benefits to the project members and the industry, through this project, we expect to get better understanding of how hybrid stack-up design and material properties influence PCB, thermomechanical performance, and reliability, and then be able to apply that knowledge to improve robustness of stack-ups earlier in the development cycle to reduce design and test iterations. And then from like a laminate manufacturer perspective, there may be opportunities to learn more about how to optimize material formulation for hybrid stack-ups. And then also members in the industry would get more exposure to new simulation approaches for PCB evaluation. Next slide. This is my last slide. So the project schedule, as I mentioned, we're trying to do this as a quick turn project. So right now we're in the call for participation phase, and then next year we'll kick off the specific tasks and hopefully wrapping up all of our simulation work by the end of first quarter 2024, and then having all of our final reports and all that done by June 30th, halfway through 2024. And so I'll pass it back to Steve now to go over how to actually join this project if you want to, and I hope some of you are going to do that. So take it away, Steve.
Thank you, Sarah. Thanks a lot for setting the scene on this new project. And now the next few slides is, of course, the important stuff on how to be part of this project. So today we have the call for participation webinar, and that signals the start of a sign-up period, which typically is about 6 weeks, but it'll probably be a bit longer this time. It'll be a bit more flexible there because of the holiday period coming up end of December, early January. So it'll probably be 6 to 8 weeks sort of minimum, I guess. And but I would say the end of this week or early next week, INEMI members can sign up and they can download the appropriate documents, and I'll go into that detail with the next slide. We're fairly flexible. The project will kick off, I think, probably end of January. But if we have members and non-members with the intention of joining, then we'll be flexible. We'll start the project with them. You won't miss out. If it takes a little bit of time to get approval and to get the documents signed off, etc. Just to remind people that aren't familiar, our meetings are held just like today by Microsoft Teams. We'll likely hold a call every 2 weeks, and minutes are taken and published. And with the participants' agreement, we record our meetings, and they can be available for those members that perhaps the times are not convenient or the day's not convenient. They can listen to the recording. As Sarah said, the duration is approximately 12 months. That's for the bulk of the actual project work to be done within that 12-month period. And that enables us to classify it as a fast turnaround project. And that's quite important for joining because it gives an option for non-members to join without necessarily becoming a full member. But I'll explain that in the next slide or two. So sign up for members. As I said, membership is required to join the project. Now, for existing INEMI members, it's a pretty simple process. On the website, next to our project, under projects, you'll see this hybrid PCB project detailed, and you'll be able to download the project statement, the PS, complete it and sign it. There is a feature now where you can electronically sign the project statement document. Alternatively, you can you can print it off, sign it, scan it, and send it back. But either way, you can send it back to me, email back to me. You'll need a signature on it of the people that are going to participate in the project, and also a sort of management approval sign off on it. Once I receive it, then that goes to Grace O'Malley, the INEMI VP of Technical and Project Operations, who will countersign and approve your participation and send you back the project statement with acceptance. So a fairly simple method for INEMI members, and I guess you're all, those INEMI members on the call, probably familiar with this already. Now, for non-members interested in the project, first I would like to say, please consider INEMI membership. There are so many more benefits of this one project. So I suggest without delay to contact me or any other INEMI staff member in your region. And again, the INEMI website has the full contact details. And then we can arrange a one-to-one call to describe the full benefits of membership and support you in your decision to join INEMI. Now, this is a fast turnaround project, so we do have a fast turnaround membership option, and you can join as a fast turnaround member for a one-off fee for just this project. In doing that, you can download and review the statement of work and the project statement, but you'll need to contact me with my email me for an MOU, a Memorandum of Understanding, which you also need to sign up to the project with. And you sign the project statement, the PS, and the Memorandum of Understanding, the MOU, and return them both to myself. Now, if you're a relatively small company, then it may be that full INEMI membership fees, they're published on a website and they vary on annual sales, annual turnover. And it may be that some of the smaller companies, it may be cheaper to join as a full member rather than a fast turnaround member. But we can help you with that decision. I just mentioned that as well. And of course, full membership, you get a load more benefits of roadmap and the ability to join as many projects as you're capable of having resources for. So that is the method for INEMI members. So INEMI members can just download the project statement and complete it before. Non-members, I would recommend to contact me as soon as possible. So with that, we're just about finishing this webinar at present. I'll leave this slide up, which is my email address, where you can note it down, and you'll find it on the website anyway, and probably by emails have already been sent. And we will follow up with everybody registered on this to this webinar. Are there any questions? Now, for any questions, you have been, as I said, muted. So if you have your Microsoft Teams window, you should be able to see a chat function at the top. And if you click on that chat function, you'll be able to type in your question, and Sarah and I should be able to see it, and we'll do our best to answer it. Alternatively, if you think of a question afterwards, or if you prefer more personal approach, then just email me on the address you can see. So I'm going to pause for a few minutes, and again, thanks Sarah for a presentation on the project, and for all of you for joining, and just pause and see if there's any questions you may have. And those questions could be on some of the other PCB projects and initiatives. The earlier ones I showed are more concerned with PCB fabrication and associated materials. We have a significant number of projects on PCB assembly, on packaging, and on environmental sustainability issues, and many other topics, and optoelectronics as well. And I'll do my best if you have any questions on other projects.
And Steve, I can't see the chat function, so if any
Okay.
questions come in, go ahead and read them out for me.
Well, sorry, yeah, I'm just opening up the questions now. Yes, we have one on the projects on the website. I think we've got a bit of time, so I might try and show you the INEMI website, if I can. Let me come out and let me try and find the website before. Let me then move it across. Here we are. You can prompt me, Sarah, if you can't see anything. So this is the opening page of the www.inemi.org, and under projects, you have three categories: in progress, in development, completed. I should know this when the project is in development. Yeah, here we are. So this is in development, and you'll see the categories of projects that have started. There's two under PCB laminates. In fact, the CAF and ECM failure has started already. It literally just had a first meeting. This is the hybrid one. And really at the moment, it just details the core participation webinar. But very soon, the SOW and project statement will be uploaded in the next few days to this to this particular page for the hybrid PCBs. Let me go back one, and I should be able to show it with the, here we are. This is the CAF project, and you can see here there's the project statement here, which you can download, and the statement of work. And this is a very similar document to the one you'll have for the hybrid project, where you just sign off. This is for both for INEMI members and non-members. And non-members that want to join the fast turnaround project, then you'll have to email me to get the MOU. And there's a link for the for a webinar presentation. But we'll send you this link, all of you that's registered and attended. So hopefully that is clear. So it's inemi.org, and then go to the projects page. You can see the other projects as well that are in progress. It's a good area if you're thinking of joining. You can see the range of projects that we have. Let me get out of that. Again, if you have any problems with downloading or the project statement or any other information, don't hesitate to contact me. As I said, the documents will be uploaded on the website against that hybrid PCB project page literally in the next few days. Pause for a few more, for a minute or two. See if there's any more questions. Or if you wish, Sarah or myself to go back to any slides to clarify any point, then don't hesitate to ask us. Those that are going onto the INEMI website, there's also all our current members listed there as well. It's a very up-to-date list. So if you like to know which other companies or organisations belong to INEMI, just go on the website and under membership you'll find the members list.